Hi everybody. So I want to talk a little bit about like displacement and velocity. So first off, I want to start by talking about displacement. So displacement can really be given using either d or x. However, there is a difference between like displacement, or rather velocity and displacement and like distance. So basically, let's say I have like, let's say I start out here, right? And let's say I go here. Let's say this is 10 feet. I go from here to here, another 10 feet, here to here, another 10 feet, and then back. I'm gonna try and straighten that up a little bit, right? My total displacement is 0, right? These are all 10 feet, 10 feet, 10 feet. My total displacement is 0 because displacement is the distance you are from the place you started, right? Where you end to the place you started. Because I started here, I'm gonna call this point A, and I ended here, there's no difference, there's no displacement. However, there is a distance traveled. I went 10 feet here, 10 feet here, 10 feet here, and then 10 feet here. So my distance traveled total is 40 feet. However, my displacement is 0. Next up, I'll talk about velocity. So velocity is given by x, I'll say delta x over delta t, as the limit of delta t goes to 0. Now, don't worry about all the funky jargon. Basically, just know that velocity is like your distance over time. Basically, not necessarily your distance traveled, yes, but like most of the time it's gonna be like displacement, okay? So like yeah, that's the formula you're gonna use. I think it is also, let me see. Speed is the rate of actual distance traveled over time. So that's another thing to know. Velocity and speed can sort of be looked at as different quantities. Your speed is going to be the magnitude of your velocity. The reason I say that is because velocity is also a vector. Velocity has direction and magnitude. So while I might say, like, okay, a good way to put it is I'm going 50 miles an hour, right? That's a speed. But if I'm going 50 miles an hour maybe east, that can be looked at as like a vector, right? So that's another important thing to take into account. Let me see. It's also good to know. So I'm gonna say that velocity, the formula we're gonna use totally is delta x over delta t. So this will be our average velocity. Let me see. So average speed accounts for distance traveled, average velocity does not. That's just like, okay, I saw an example saying like, oh, the earth revolves a certain amount in a year, right? So the earth is revolving, right? Let's say it starts here, we take that point and then it revolves. Not exactly a circle, but you get the point. Ends back at the same spot in a year, right? The average velocity is going to be 0, but the average speed is going to be whatever it's going to be. It's going to be whatever your total distance traveled is over the amount of time that you took, which would be like a year, and you might convert that into seconds or something, right? That's also a good thing to note. I'm going to go ahead and end the lesson here. I hope this sort of we're going to do example problems and everything, but like I hope this sort of quantifies or qualifies like sort of what your understanding of velocity and speed and distance traveled and time and things like that are. Notice that we can manipulate this equation to maybe solve for like our displacement, right, over time, or our time in relation to velocity and displacement. But it's good to know that. Also, don't forget to take into account the average velocity and the instantaneous velocity. Velocity here is your instantaneous velocity, your velocity at a given second, right? Well, at a given point in time, right? Because we can see as this limit goes to 0, that sort of, it's the limit goes to 0, so it's sort of your instantaneous velocity. But this is your average velocity, so it's good to take that into account. Yeah, if anything was unclear, just don't be scared to like comment in the comment section. Hopefully I can answer your questions and everything. And please don't forget to like and subscribe. Thanks.